Hello, can you hear me? So I thought we might make a start now. Um, so sorry about the hold up, but I just thought, well, wait for the maximum number of students. So the very first thing I'd like to do is to just talk a little bit more about the assignment um, and the different kinds of things that we have to do for it. So I'll just bring that up on screen. So you should hopefully be seeing my third screen here and seeing the Word document that covers the assignment. And so the assignment is all about developing a booking system for the driver's license test booking system. If you wanted to get your driver's license with the NZTA. And we'll just have a look at the meeting controls as well. So one of the things that we have to think about when we're developing this type of project is the data structures and algorithms that we need to handle our project. And so I suppose my first question is, what kind of data structures and algorithms do you think we'll need to use for this particular project? So don't be shy to, yeah, an array is a good option. Don't be shy to come online and speak. I mean, you don't have to put your video on, but it probably makes it a bit easier to have a conversation. And yeah, an array is a good way to look at this, and it's one option. And so over here, we have a two-dimensional array for all of the different days of the week, and then also all of the different time slots, all of the different hours, just matching up with what we have in the assignment requirements over here. So things like the booking time slots, they start at 9 a.m. and they finish at 5 a.m. So the time slot at 1600 hours, that covers the time slot from 4 p.m. to 5 p.m. or from 1600 to 1700. One of the important requirements here is that you're allowed to have 8 bookings per time slot. Sorry, that there are, that you can have 8 bookings per day, right? So we've got each of those handled with this requirement here. So 9 through till 4. But one of the other requirements is that you can have 10 driving instructors available for each time slot. So what that means is that our data structure is also a little bit more complex. And I think I quickly misread the requirements earlier on, but this is still going to be representative of what I'm thinking of. So another way to think of this is that, you know, you've got your days of the week, you've got your times, right? And each of those is an individual cell, but then your abstract data type, it's going to need to be, it needs to have another dimension as well to handle those 10, I've got here 8 slots, but that's not quite right. It should actually be 10. I just misread the assignment documentation. But there are a total of 10 driving instructors for each available time slot. So you also have to think about that extra dimension, I suppose, and how you can model that in your inside of your system. So the way I look at this is very much like this. This is what comes to my mind almost immediately. But as I say, you know, there's multiple ways of doing this. Somebody's mentioned using a database table, and that's also another good option. So there are multiple ways of doing this. The way that I want you to do it using the assignment is to do it using an in-memory data structure. So you really are only limited to things like in-memory arrays, linked lists, trees, all of those kind of data structures and algorithms. Do we have any questions about this so far? Or I'm sure you'll have questions once you've read through the documentation for the assignment, but this is just something to prompt your thinking. And again, this should be 10 slots, not 8 slots. I just made a little mistake there. Okay. So one of the things that you need to do with your assignment is to develop these APIs, things for like booking a time slot, retrieving time slots, and so on. And one of the other things that you need to develop is a suite of unit tests to exercise your code. So I thought it's probably a good idea to go through and have a go at implementing some of the, not the entire functionality that we've got here, but some of the functionality that is required in the assignment. So we'll go through and create a new project. All right, so you should see here the dialog box for creating a new Android project. So most of the coding that I'll be doing this afternoon is fairly low level. It's not really mobile programming specific, but you know, it'll give you a good feel for the type of thing that you should be doing in that first assignment. So we'll go through and we'll call it DTBS. We'll select Java as our programming language and let the IDE create that for us. And so what I want you to do with this assignment is really perhaps not start with question 1 straight away, but have a think about what kind of data structures and algorithms you want to use, what type of abstract data types you want to use when you come to develop this application, and also to try and be a bit more test driven with how you actually implement the assignments. So here we have a blank Android program. And so one of the things that you can do is to just scaffold your project on top of the existing project structure that's been given to you. And so what I'm going to do is just run through some examples for implementing your project in a test-driven way. So we'll just wait for this to compile. I'm a little bit worried about, I want to rename this unit test here, but I'm a bit worried about renaming it while I'm building it down here. So I'll just let it build a little bit longer. Okay, and here we go. So sorry, still, oh, looks like it's almost finished. Looks like it's finished now. And so we're just going to rename this just using the refactor tools, going into refactor and go into rename. And we're going to call this the time slot unit test. And so you can see here that this is a little unit test. So we have what's called a so-called annotation. So annotations, they all start with this @ symbol, and then you have the name of the annotation. And so that is actually a behavior, if you like, that we can apply to this method. And so the @test annotation tells Android that this particular method is going to be a unit test, and so that it needs to run that unit test with the JUnit test harness. And so you can see over here we've got a play button, and that will allow us to play this individual test. And we've also got a double play button up here, and that's going to run all of the different tests that are available in this test suite. So we'll just run the one. And normally this shouldn't, the nice thing about this is that it shouldn't fire up the emulator. So what we're looking at doing this afternoon is just the core fundamental parts of the assignment, right? And having a good think about the in-memory data structures that we need. So we just let that run. Okay, and here we go. And so you can see here that when you run it inside of JUnit, it doesn't run as an actual mobile application. It runs as just a test application, if you will. And so you can see that the addition is correct. Method is just testing that 2 + 2 is equal to 4. And so that's a very, very simple application. And so one of the things that we want to do is to implement a new test. So normally with my tests, and also to be test driven, what we want to do is actually create the unit test first. So this is a fairly standard industry practice. Normally, a lot of these things are there's set guidelines that people talk about and adhere to, but normally people are kind of like loosely interpret that, so you don't have to be so purist. You don't have to be such a purist, just do what works for you. But we'll start off being test driven. And so what that means is you actually write the unit test first, right? But you have to, at the same time, we'll have to start writing some backing code, some in-memory data structures and things like that. So one of the tests that we might like to have is a test method test make one booking, and we'll also say should pass, just like this. And so one thing that's important with unit tests is they normally don't take any parameters. So normally you just have a method, and there's 0 parameters for it to work as a test. So I'll add the test annotation, And then we'll just say so we've got this assertions library that's built into JUnit, and we can just say assert true, and we'll just assert that true is true just to get this test working. And then so over here we can run all of our tests again. Okay, and so you can see there that our new test is working, but it's not really doing anything useful, right? We need to add some code for that test to do something useful. So what I'm going to do is to start thinking about my data structure, the different abstract types that I want to have in my system. So what is our system all about? What does our system actually do? It's all about booking licenses. So I'm going to create a new class called bookings, like that. And so that's been added to my main project. That class doesn't do anything yet, but we can start to add some skeleton code to that. So one of the methods that we require is the book time slot method. And that takes a user. It also takes a day, and it also takes an hour. And I believe that method also returns true or false. Like this. So we now have a booking, the skeleton for our bookings class. And so over here, we don't really need this addition is correct method. That's just a placeholder value that you can build into your program that gets given to you. We don't really care about that though. So we're going to create some test bookings here. And then we're going to, we might leave the assert true as just as a placeholder there. And then we're going to look at using the bookings object that we've just created to actually make some bookings. So we're going to book a test for John on Monday at 9 a.m. So we're kind of thinking, I guess the way that we're thinking about this is we're thinking of our system from an external point of view, right? And from there, we then have to, and from there, basically our program's now not really doing anything. So this here should probably return false because a booking has not been made. And we can get that value in a return value. And we can use that here. And so we can run our test again over here. And so the idea with test-driven development is that you think about the tests that you want to have, right? And then you can use that to scaffold and build the rest, the remainder of your application. So that's now failing. And so with the purest point of view with test-driven development is that you now go away and you build that functionality. But you only build enough functionality to get this first test passing. Okay, so we now have to have a think about how are we going to do this? Okay, so we have to think about what kind of data structures and algorithms that we're going to use, and how we're going to key into these values. So we need to record the user, the day, and the hour. And we also have to go through the logic and work out, are we able to make a booking or not? So how do we save this information, guys? We've got 3 tuples or 3 tuples. How do we save these? So one thing that we could do is we could start off with an array list of strings, and we can call this time slots. And we can provide a little templated string type there so that we can use that. And then from there, we can do things like add the user. But there's a problem here. Can anybody see what the issue is? There's a couple of little problems that I can see. So nobody's saying anything. Has everybody's microphone stopped working?
And just still
We can see what the problem is here.
my brain just still loading the program.
So when we add a new element into our time slots array, right, we can add in the user, right? But what happens to the other? What happens to the other parameters, and how could we get around this?
Adding another tuple into the list, adding the data as a tuple. Adding the adding the data as a tuple into the list.
I can hear you, Robinson. Yeah, I could see your microphone working, but I think I had my speakers set to my monitor, and it wasn't the cable wasn't plugged in for that. But I can hear you now. I've just switched.
Okay.
What did you have to say?
So I was thinking, turning those data into tuples and adding that into the array list.
So how would that look?
I did this in Python once. Tuple bracket. Tuple. We had to make a new variable.
New variable? Are you sure it's a variable?
No, make a new tuple.
Okay. When you say tuple, what do you mean? What are we gonna? If we're talking about an Android program, what's your tuple going to contain?
Those 3 datas.
Okay.
User, day, and hour.
Okay. So if we're going to create an abstract data type that represents that, how are we going to do that in Java?
That's where I'm confused.
New class with the 3 member variables.
Yeah, exactly. We're gonna create a new class. So I think it's just so we're going to create a new class, and I'm going to take the liberty of just calling it time slot. time slot, or we'll leave it at this time slot. Yeah, so I think there's probably just a little bit of confusion about terminology, but you can use a class as a structure basically. So I'm just going to grab these values or these parameters, and I'm going to whack them into my class. And so now we have a nice time slot class, and to make everything a little bit nicer, we'll encapsulate those values and make sure that they're private. And what we'll do next is we'll use the code menu and the generate function. And what we'll do is we'll generate a constructor. And we'll generate a constructor using these 3 variables. And so now we've created our own little time slot class. And then over here, instead of having, so this is tying those parameters, right? The user, the day, and the hour. That's critical to this application, right? And this is one of the things that people have problems with when they first start programming. How you arrange this in memory, how you can develop a structure to hold on to all of these different things, this is confusing. And it is actually very complicated. So over here, so things I've seen people do to try and solve this problem are things like this. So instead of having a structure to hold on to all 3 variables, so this is what I'm doing now is what I would normally consider to be the wrong way of doing it. So what people often do are things like making different array lists. So you might have an array list for users like this. And then you might have an array list for days, and then another array list for hours. And of course, the array list for hours, that would need to have an integer data type as well. And then, you can, of course, add all of your parameters, all of your tuples to those array lists. But there's a big problem with this. Can anybody tell me what the problem is? Okay.
The values are switched.
Yep, the values are switched. But there's an even bigger problem.
Oh yeah, the time slot hours should be converted into a string before putting it in. Never mind.
So this works, right? So it's now finally working, but this kind of structure, right? This is what I would consider to be too complicated. So we've introduced a lot of complexity into our program, because now instead of having 1 array list, we've got 3, right? And then we have to manage 3 separate array lists, and we also have to make sure that all of the different array lists, they are all in sync with each other. If they ever get out of sync, then it's going to make our program even more complicated. So this is, I guess this is probably one of the warning signs in your program, right? If you find yourself having to write multiple lists to hold on to the different tuples of data, then you're probably doing it the wrong way. So we actually have a really good solution. We can fix this. And I think once I've fixed it, you'll see that it's it's not. It's more like, you know, fixing quotation marks. It's just a different way of thinking about it, I suppose. So we're going to use our time slot structure, and we're going to have a time slots array, and inside of that, we'll have one array list, and this is much better because we don't have to worry about the synchronization between each of these array lists, and that extra level of synchronization, you know, that adds a lot of complexity to your code and a lot more opportunities for there to be bugs in your code. So we'll get rid of this. This is not the type of code I like to see. So over here, we've got our time slots. And what we want to do is we want to add a new time slot. And that's going to be constructed from the day and the hour. And so that type of code already, well, to me, that looks a lot, to me, that's a lot simpler. So over here, we're still missing some information. Our program's still missing some functionality. So if we go back to the assignment specs, we'll just have a look at that. Okay, so what we're looking at here is the data structure that is going to drive question 3, 4, and 5, right? So we have to consider all of the different requirements. And what we've so far done is to put those parameters, the license number, day, and hour, we put that into a structure, we've put that into the list, but we're missing something. So we need to return true if the slot could be booked successfully, and we also need to return false if it can't be booked, you know, if there is a double booking. Okay, so other things we need to remember are that the time slot can be booked by 10 users at the same time, and one user can only book one time slot per day. So if there's more than 10 users for one time slot, then we have to return false, right? And if there is, if we have the other condition, we also have to return false. So we have to start thinking about those situations. So how do we code that kind of behavior into our program over here? So I've got to have some extra validation with our program. So right now, this is, I guess, the simplest type of functionality that we could think of. The basic operation, so we return true. And we can insert true over here in our unit test. So we're kind of writing some automated unit tests that are rerunnable. And also, so we can exercise our code, and at the same time, we're actually writing that code as well. And so we'll just run our unit tests again. Okay, so here we go. And we've got test make one booking should pass. Okay. And so let's make another test. And we can do test make 2 bookings. 2 bookings same day should fail. Okay, so we're slowly building up the functionality of our program. And so what we'll do here is we're going to book that again. What we're going to test now is this this third bullet point. I'm kind of doing everything in this assignment out of order. I'm just kind of doing it in the easiest to understand order possible. So that's easiest for me, but you know, do what is easier for you when it comes to the assignment. Everybody's different, right? Okay, so here we go. So we're booking that third, we're testing that third bullet point. So we're going to do another booking for John, and we're going to book on Monday, and this time we're going to book for 10 a.m. as well. So that should return false, right? That shouldn't be possible. So if we run this test, if we run our tests again, this test here, what do you think will happen? It should be quite obvious what should happen.
It should, in our case, it will fail.
Yeah, exactly. It should fail. So I'll run it again just to make sure that it does fail. Okay, so it's failing, and we can now we can go back into the code for book time slot, and we can handle that extra case. So how do we handle that case of a booking made for the same day? What do we have to do here, guys?
We have to loop through our array list to check that.
We sure do. Exactly. So time slot, and we'll just call this time slot. So we need to do that check, and we need to and I think we can actually, so our time slot class, it needs a bit more functionality. We need these variables here, well, these data items, they're all private, so we can't just pull them out of there. So I'm going to just go up to my code menu up here and also generate some getters and setters. And I always like my getters and setters to be at the bottom of the class, so I'm going to just cut and paste those. Okay, here we go. So we've got our getters and setters there. And what we are going to do is just check if we have a booking for the same day. And we use our dot equals method and compare that to the day parameter that has been passed in here. And then we can add a little if statement. And if that condition is true, what should we do here if that condition is true? So we're going to want to toggle the behavior of our little method. And so we're over here, yep, Yvonne has just put the comment in there, return false. So then we can test our program again. And so this really helps with the quality of our application, because we can make incremental changes and then we can immediately test it. And at the same time, we can still test that the earlier parts of our program that we've developed, we can also test that those still work. So we'll just run our program again. And you can see now that we have two passing unit tests, which is a really nice thing, really good to see. And so you can see here that we've got a partial implementation, right, of this book time slot method. So what else do we need to add here? What else do we need to test for to complete this this particular method? So we also need to implement this method here, or not this method, but this functionality. So we also need to have some extra unit tests to have a look at what happens when we book the same time slot 10 times. So we'll implement some extra code for that. So we'll make another test. And so test. So when I write my unit test, I always like to explain what I'm doing. So we'll say test make 10 bookings. And actually, well, we don't want to make just 10 bookings. We want to make 11 bookings. Should fail. Right, and so again, what we're doing is we are just exercising the code in that book time slot method. Whoops. Okay, and so it's this time it's for the same time slot, and we've got different users. So I'm just going to just do this. You could probably do this in a for loop as well, but I always find it useful to do these test cases with all of the data explicitly set out so I can see what has to happen. Okay, and so we've got user 9 and we've got user 10. So up until this point, everything should return true. And then for user 11, it's that we're talking about that same time slot on Monday morning. That should return false, right? So we'll run our code again. And so this is going to be another failing test case. And it's going to fail simply because we haven't implemented the extra validation for this method. So let's run the code, let's run the test. And so this is a really nice way of incrementally creating your application. And so you can see here that the assertion is failing because we haven't implemented that check yet. Okay, and so we can come in here, and so we need to do some extra validation. So how do we do that, guys? How are we going to check that extra validation? How do we have to change our this to actually implement this functionality? We're going to have to make some changes to our system. Yeah, we can use a counter, but if we use a counter with this assignment, I've kind of cheated because I know what's coming. But if we use a counter, we won't be able to implement some of the functionality required for question 4 or question 5, where we have to get all of the information back. So a counter is a good suggestion, but we need to think more complexity. Use dot length. Okay, so how could we use dot length? Could you be a bit more precise with how we can do that? What it means is that we need to, with our time slots, right? It's not just a matter of keeping track of these tuples, but it's also a matter of keeping track of how many users there actually are. Oh, this is in my mind how I would implement this. And the nice thing about this is that it's all kind of wrapped up and encapsulated inside of the time slots abstract data type. So what we can do here is to make this a list, right? And we'll create a list here. And so we need to refactor our time slot class a little bit. And the way to do that is to just, I think, get rid of the user. And we need to update these methods. And we also need to make this a little parameter over here. User. And I think this needs to be users as well. And we'll make this plural as well. And so now we're changing the functionality of our time slots abstract data type quite a lot. So we'll remove that from there. And yeah, what we actually need to do here is to, well, there's multiple ways of doing this, right? I'm going to try and go with the way that is the simplest for me. So this code here is going to change quite a bit. So we'll create, and by simplest for me, I also mean simplest for you guys as well. So what we're going to do here, instead of, up until now, what we've been doing is we've been adding the time slots on the fly as we needed them. But I think to really implement the multiple users per time slot, I think we actually need to pre-generate all of our time slots. So the way that we'll do that is we'll use a loop, and we will create some new time slots. So we'll do that like this, and yeah. So we'll just make a loop. So this is going to be a new little data structure. And just bear with me while I populate that. I can do this. So we've got Monday. Let's try and do this as fast as possible. So I'll put these values in there. Wednesday, Thursday. So the way I'm doing this is I pre-generate my time slots. I'm just creating a little array of strings so that I can iterate through those. And then over here, we'll create another nested for loop to populate the hours. So I've got the counter here for J, and I want to use that to populate the hours. What should J start at, guys? I just want to make sure people are following along.
9.
It should start at 9, exactly, yeah. And we're going to want to do J is less than, what is J going to be less than?
The closing hours.
The closing hours, yep, exactly. And then we're going to do J++. And so we're just generating all the possible time slots, right? So this is going to be the day, and this is going to be the hour. Oh, and what's the problem here? So this should be easy for you guys.
The constructor does not matches that data type.
Yeah, it doesn't. And what is the, so it's an integer, right? And the constructor,
is, I think, user was removed, I think.
And the user was removed, and so what it wants is a string, which is the day. And so what we want to do is we want to use this I value to index into our days of the week array. So I just forgot that I need to put that little thing there in there like that. And so I can use that to populate all of my time slots, just like this. So we've got all of our time slots. We can delete these extra little squiggly brackets. And so that's changed my program quite a lot. So I'm suspicious now that my program is not going to work for these earlier unit tests. So I'll now run those again. Right, and unbelievably, the first two still work, but they actually shouldn't be working. So that just, I suppose, shows you some of the limitations, perhaps, of of unit tests. You still have to use your brain because this has a problem. Line 24 has a problem. We've pre-generated all of our time slots, right? Can anybody tell me what is the problem with line 24? While you're thinking about that, I'll toggle a breakpoint in there and I'll run through and we can debug our unit tests as well, which makes things really nice. So I can toggle a breakpoint there and we can jump into the code and look at what's happening. Okay, so we've got a breakpoint here. And so we've got 40 existing time slots now. And those time slots, they're for Monday, 9 a.m., 10 a.m., 11 a.m., so on and so forth, right? Now the problem is line 24, what is line 24 doing? It's adding another time slot. So, and it's adding another time slot for the day and the hour that's been passed in. So we don't want to do this function anymore. So you have to still have a good understanding of your code, even if you are using unit tests. So what we want to do now is something a little bit different. We want to iterate through the unit tests, and we want to get the time slot day, and also and we want to compare that with the day parameter. And what we also want to do is get the time slot hour, and we also want to compare that with the parameter. And so what we're doing here is we are searching through the list now and selecting the time slot. So when these parameters are true, right, that means that the time slot that we've passed in is a match for one of the predefined time slots that we've created, that we've pre-generated up here for those 40 time slots. And so when that's, so I'll just comment out this code and we'll stop our code again. And so what we're going to do here is get the users, and then we're going to add the user to that particular time slot. So we're no longer actually creating more time slots. We're just getting the actual time slot and then adding the user to that. And that'll allow us to do those extra more complex behaviors a little more easily, I think. So you can see we've totally revamped our abstract data type. And you know that normally that's a big deal, but it's okay. We can change our code around. And this is the type of thing that you'll have to be doing all the time as you're programming. So I hopefully I didn't lose anybody when we kind of made the jump from adding the time slots on demand as we needed to do that. We kind of jumped from doing that, right, to the idea of just pre-generating all of the time slots. And then once we've pre-generated the time slots, we then need to use a for loop to search through all of the time slots and then use that to add the user to our time slot. And so we can return true here. And we're returning true there as well. And we'll delete this extra little bit of code because we don't need that anymore. So this is clobbered. These code changes that will have broken some of our test cases. So this is particularly where test cases are useful. So we'll just run these again and see what happens. Okay, so the first one now passes, but the other ones, they are now failing. So so we have to do the we have to re-implement the same day time slot. And so how do we do that? How do we re-implement the same day test? Make 2 bookings in the same day should fail. How do we implement that now? What extra functionality do we need to build into our little search engine here? So we probably need to add in another little if statement, and we can say get the day, and with this particular validation, we want to be matching up on the day parameter that we pass in, right? And from there, what do we want to check? We want to check if the user, yep, I can see Yvonne is thinking about what I might be doing, which is good to see. We need to compare the user that we've passed in to the user list that that we've got available here. And so and we also have to think about what is this here. So we've got a list of users. What is that? That's an array list, right? So if we want to match a single user into this list of users, what do we have to do? There's a really nice method. In Java called contains, right? And that will return true or false if that array list contains the item that you pass into it. So over here, we can have another test that looks like this. And if this is actually true, then we want to return false. And so we can now check how that works with our unit tests. And it's still failing. I'm not sure what the problem is now. What we can do though is we can jump into the code and we can debug it. So we can debug our little unit test here. And what we want to do is, there's 40 time slots, and I think it just so happens that the first time slot is Monday 9 a.m. So that's good news. And oh, I think I stepped through the code a little too fast. So I'll just do that again. So the first time we run it, we're running it for 9 a.m. and so we'll just play it again. And here we are running it for the 10 a.m. parameter. And so we'll just step into the code. And I think I keep switching from Macintosh to Windows, and it's messing with the hotkeys I'm using. So I'll just try this again, sorry. Just debug this again. Okay, so it's the 9 a.m. parameter. We'll just run that code. I'm pushing F8 instead of F6, I think. Okay, so we want this one, which is step over. And what we want to do is we want to see what's happening here. So the time slot that we've got here is the TS object. The day for that is Monday. Okay, and I can see that we're going to have well, actually, no, I think that's okay. And so we can step into this. Oh. Ah, yes. Right. Okay. Right. I think my logic is working, but my code is not quite working. Okay. Right. Good. I'm glad somebody's thinking. Okay, let's fix up our unit test. Monday. Okay, that's good. And we'll just change all of these as well. Okay, let's try this. So I'm actually really tempted to just run this again now without debugging it, so we'll just run it. Okay, and so that's working. So I think that little bit of code where we're checking this condition, that's now returning true. But the other problem is that we aren't checking the greater than 10 time slots booked. So we'll run that unit test. And that's this one over here. Okay, so that one's still failing. And so we need to put an extra little check into our code over here. Just to make sure that we don't have more than 10 users booked for the same day. So how do we do that, guys? Any ideas? Do we do the check inside of the loop? Do we do the check outside? I guess we have to do the check inside of the loop. So we've got our time slot object, right? And we need to check if we've got 10 time slots. Or if we've got 10 users. So we can use our users array again. And we can say if the size of that is equal to 10 or is greater than or equal to 10, then what we can do is we can also return false. So we've gone from some rather simple functionality and we've kind of overlaid more and more complex behavior. So I think this might just about do it. We just need to make that greater than or equal to. I mashed the keyboard a little bit there. And we'll just run the code again and we'll see what happens. Oh, and it's still passing. Where am I going wrong? So if the time slot dot users dot size is greater than or equal to 10, I think I know what the problem might be. It's because we're not locking on to one particular time slot. So we might have to include that check in here. We'll put this little bit of code here into the else block. And so we'll run that again. And oh, so it's actually working. It's my bad. I think it was working the first time around as well. It was actually working. Okay, that's good. So that's a good example of, you can see that the last assert is actually failing as well. So if we add any more users to that, like user 12, it's also going to fail. So we'll just run this one again. And okay, so that's also failing. We'll bring it back to 11 just to make it consistent with the naming of the method. So there's another test case that we should do here to absolutely guarantee that our book time slot method is working. Can anybody think of what other kind of conditions there are that we should actually check for here? I suppose in a way we've kind of built those extra checks in here. Yeah, we're kind of testing the hour because we're testing the same, we are testing the same hour. But we could do another test over here, and we can just call it test multiple bookings, different hours. And what should happen is they should pass. So they should all be positive tests. Okay. And so all of these should pass. So that passes. Some other simpler tests that we can do here. What happens if somebody tries to make a booking for an hour that doesn't exist in our booking system? What should happen? It should fail. So for example, we can make a pretty quick test of at test, and we can write a quick test saying public void test 7 a.m. booking. And what should happen is it should fail. And we can say assert true. So assert true is just going to use the return value that we return from the book time slot method. And we can just use the John user again. And we can use the Monday time slot. And this time we can use the 7 a.m. Booking slot. And so that should actually, it shouldn't return true. It should actually fail. But we don't have this extra kind of functionality built into our system. So this is actually going to fail. So you can see there that we've got the 7 a.m. booking, that test fails. So, you can see that, if we use hours that are out of range, then it breaks our test case there. So these are some of the other kinds of test cases that you should think of. If we did another one, we can do public void tests Saturday booking should fail. So these are all the different types of test cases that you should think of when you're designing and developing a system. So we can have a Saturday booking, and we can also have that's set for 9 a.m. And again, this test case should fail, simply because we don't have those extra types of validation built into our system. So this is just a very small, simple example of how you can set up the assignment, and also how you can set up your unit tests, and just some of the different types of unit tests you should be thinking of. How many unit tests do we have here? It looks like we've got 6 unit tests. So ideally, you should have a suite of 10 to 15 unit tests for your first assignment, doing both positive tests where you expect something to pass, and also the negative type of unit test where you should expect something to fail. So the solution for a 7 a.m. booking, right? How do we fix up a 7 a.m. booking? Any ideas, guys? This should be easy, easy, easy.
Contains hours. Maybe we can just check.
Yeah, it should be even easier than that. So this was the range of hours that we look at, 9 to 1700 hours. Can we use that? And how could we use that?
Is it less than 9 and greater than 17?
Yep, exactly. Exactly. So there's no trick question here. So if the hour is less than 9, or the hour is greater than 16, then return false. It's as easy as that. And so we can run our unit tests over here again. Okay, and here we go. Somebody's saying get hours is not equal to hour. I think that's what you were talking about here, perhaps. And so then we've got a Saturday booking should fail. And so how could we fix that up? How could we fix that kind of condition up? I think we probably just need to change that to false. If you go through all of the list of time slots and you haven't matched anything, you probably just need to return false here. So this is when I'm talking about building up incrementally more complex behavior. This is one way to do it. Oh, test make one booking should pass. So you can see how if you change your code, it's really handy to have unit tests. So you can see that changing this to false here, that has now clobbered the first unit test. So that'll tell you, if there's some kind of unforeseen follow on kind of problem that you've introduced into your program. So very, very useful to make unit tests. You have to do it as part of your first assignment. The code that I have just run through is just an example. You'll need to have a good think about what you want to do for the first assignment, and you'll also need to develop extra code for the other parts of the assignment. So you'll definitely need to develop user interface code, and you'll also have to develop code for these extra APIs like getting the slots, getting the time slot bookings and that type of thing. Getting a list of aggregate values like counts, frequencies, that kind of stuff. So there's a bit more that you need to do with the assignment. This is just an introduction. So that's that part of the class today. I just thought I'd give you some idea of what you have to do for the first assignment and the types of things I'm thinking or I'm expecting to get. I'll make sure that this code is up on Moodle as well, so that you can extend it and improve it and fix up things like this, these extra little bits of code and unit tests that are passing and failing and that kind of stuff. You guys can fix that up. You've got enough unit tests and behavior here to get started, validations and things. And we'll go on with the next part of the class, which is where I want to talk about the basics of navigating in an Android application. Okay. So what I want to talk about, no, this is coming up on the wrong screen. I'll just switch this around. Okay, here we go. Okay, yeah, that's better. So we've got a couple of slides. These are also available on Moodle. So I'm going to chop and change between the slides and also the little example project that I've already prepared. And you know, if you have questions, feel free to ask as we go. Everything that I'm recording today's session, so we can also put that up on YouTube or wherever else after the class. So what I want to talk a bit about today is how you can create messages inside of Android to navigate between different activities. So with your first assignment, it's likely that you want to have some kind of navigation built into your project. So the stuff that I'm talking about now, it's the driver for some of that is the first assignment. So I'm just giving you a bit more knowledge so that you can fully implement that and fully realize the first assignment. So we'll talk about intents, and in an intent, I'll explain it more in a minute, but it's basically a message that you can send from one activity to another activity. So we'll have a look at that. So this is just some explanation for creating another Android activity. How you can do that just using the menu system. I think we'll have a look at the pre-prepared example though, and I'll show you how that all hangs together. I'm just going to close this time slot helper that I've been working on. Okay, so here we go. Whoops. Just resize the screen a little bit. Okay, here we go. Whoops, that's not looking very good. Okay. Looks like my computer may have crashed. Just give me a minute to get this back. Oh. What's this? Looks like a license agreement's popped up. Okay, I'm just going to agree to that. Okay, here we go. Okay, so normally in an Android project, you've got your main activity. And so what you might like to do is to create other activities. And so it's actually not too difficult to do that. You can just go to File, New, and New Java class. I've already got my second activity, and so you can create the Java class directly. Alternatively, you can also come over here and create a new activity using just the Android Studio code generation. So you've got empty activities here, login activities, all sorts of things. I've already got all of these, but we'll go into creating an empty or a basic activity, probably is the better one. So you can create one of those, and you can give it a name, and I'll show you how this ties into everything. So I've already got a second activity. I might just call this main activity 2. The important things here are that we've got the name of the class. So the new class is going to be called main activity 2. And the other important thing is that it's going to have its own layout, right? So I'll just go into that again. So you can just go into File, because it's easy to lose track. So you go File, New, and then Activity, and then Basic Activity. So normally with these things, there are a lot of different options, but we'll just go into Basic Activity. And then from here, you can select those. The important parts are the activity name, that's the name of the class, and also the layout name. So we'll just finish that. And so what's happening here is that Android Studio is generating the code for these new for this new activity, right? And so that you can see here, it's got its own little code that it's generated for us. And it's also got its own little layout file as well. And so we'll just wait for that to open up and render. So Gradle is just building the projects. Apologies for it for being a little bit slow. Okay, so it's still building. So it's also got the layout over here for our extra activity. So the other important thing with this is that when you create that extra activity, it also modifies your Android manifest file. So over here, you've got so everything really happens inside of your application XML code block. And then inside of that, you've got all of your extra little activities. So that activity, main activity 2 that we've just created, that has to have, for that to be linkable and for us to be able to navigate to that new activity, it has to be present here in our Android manifest file. So you can see over here on the left that we've got a number of, with this project, we've got a number of other activities and things, and they're also all defined here. Over here, we've got our main activity, and that's a little bit different. You can see here that we've got this so-called intent filter. And so these little filters, they instruct Android to tell the Android operating system that this is the main activity, that this is the main file that Android is going to launch when the user selects and clicks on the on your application icon. So there's a number of things you have to be mindful of here. You've got a label for your activity. You've got the actual class name. If you hold down the control button, you can link into that and then click into the code, and it will link from the manifest file over to the actual class file itself. Notice though that the class file defined here, none of these class files, they don't have the complete package name, so it doesn't include jkc.com.intentExample. So that's the main one. And we can also define our own intent filters as well. And so what this allows us to do is to navigate using some button controls from one activity to another activity. I'm just reducing the size of my emulator so it fits on my second desktop over here. So we've got some little buttons here. So this is the main activity here in our project, and so we've got different buttons that do different things. So the explicit intent, that is the simplest possible way of navigating from one activity to another. So we can just hit that button, and what happens is it just sends us to the second activity. So as I say, in the PowerPoints, I've kind of got the same stuff that I'm talking about here. So I'll just continue talking about it in Android Studio. You guys can have a look at the PowerPoints later on. Or over here in the main activity. So that's where everything that's interesting is happening. Okay, so the main part, the main entry point as usual is our onCreate method. We're creating an action bar, which is something that we'll look at in more detail next week. But the code for doing this explicit intent navigation is just here. So this is actually, I think this is relatively simple actually. So what you're doing is you are setting up a little message object, and what you're doing is you're just setting up where you're coming from, which is your main activity, and the current object that you've got there, and where you want to go. So there's a little method there called setClass, and so you just define where you're coming from. That's the current activity where you are, and then where you want to go. And then from there, there's another little method called resolveActivity, which is just some boilerplate code, which Google give you in the documentation, and that just shows you how to resolve the activity and then start that activity. So this bit of code is the actual little bit of code that actually does that transition from one activity to another. So you can hit the button. We've got, you know, as usual, we've got a event handler, a button, click listener set up. And when that callback executes, it executes all of this code. It sets up our explicit intent message and then executes it. So if we hit that button, we are going to transition from our main activity to our second activity. And if we want to move back, if you have a standard Android operating environment, you can just hit the back button, and that will that'll just take you back to the previous activity that you were on. So that's one way of doing intents, probably the simplest and the easiest way of doing it. The second way is to use the so-called implicit intent, which is where you can define an intent filter of your own specification. It's kind of like defining your own event instead of always handling other people's events. So you can define your own intent filter specification, and the code for that. So the actual action, right, is exactly the same. So we can navigate from the first activity to the second activity. It's exactly the same action. The code is a little bit different, and the code for that is here. So we still have a on-click listener, right? This time, instead of setting up the class where we're transitioning to from and to, we set up the intent filter that we're interested in routing this particular message to. So this is a little bit more involved, but the neat thing about this is that you can define your own intent filters, and you can allow other consumers, other applications to also call your activity. So you might develop a really nice activity for, say for example, handling camera actions, that type of stuff. And you know, on Android there are a whole lot of third-party camera application apps that you can use, and so you can define your own intent, either for a pre-existing intent, like using the camera widget, or you can define your own application as well. And this is how you do it. You set the action, and then you transition to that action using the start activity. And the action that I've defined here, that corresponds to the action that I've defined over here in my intent filter that I've defined here for my second activity. So it's just got the default category and just a custom action name, which I've just defined here. And so that's how you can interact with that type of intent filter. Normally you wouldn't do that. Normally that's not really necessary. Where that type of intent message comes in handy though is where you want to tap into some Android SDK functionality, or Android operating system functionality, or other kind of widget function, or some other type of app provided functionality. So for example, our Google button over here, that is going to take us to the web browser functionality that's built into Android. So you can see here that it's opening up my default browser and opening the URL that I define. And so that's simply defined over here in my Google button event handler. So you can define the action. So there's a predefined action view, which Android has defined as the as the intent message for opening a web browser, and from there we can send that extra information, such as the URI for a web address that we're interested in browsing to. And so that's defined, using the set data and type method over here. And so again, this is just really boilerplate code from Google. It's just something I found in their documentation, but it's something that I think is useful, and so that's why I'm highlighting it here. The other useful type of intent, if we push the back button here, it's going to return to our previously defined activity. The other interesting type of intent message is where we're using some of the internal apps defined on our system. So I was talking about the camera app before, and so we can also navigate to that as well. And so in the emulator, the camera app brings you to this little room widget, but it doesn't really do very much. It does allow you to take a photo though. And so, you can take photos and things, and you could send the photo information back to your calling application, or you could delete it or whatever. That's extra functionality that you'd have to build into your application. But that's defined by the action image capture built-in intent. So there's all sorts of complicated behavior that you can assemble for your application, either using your own activities that you define, or also using operating system provided activities. Okay, so I'm going to navigate backwards here. And so the next part is, so we've looked at Google and we've looked at camera as well. And so these are just really all variations of doing the same thing. One of the other things that you will need to do with the first assignment is you'll need to be able to send information from one activity to another activity, potentially. And so I've coded that functionality into the send message button here. So these values that I've defined here, they're all going to be sent to my my second activity. So they've all come through over here. And I'll just show you how to do that. Actually sending, this is something that people always seem to have problems with, is sending this data to another activity. I'm not sure why, but I guess it's a little tricky. So it's very similar, right, to the other types of intent messages. You're all the time just saying, where are you coming from? Where are you going? And then inside of your message, you have these extra key value pairs that you can also define. So you can define things like a client ID, a first name or last name. However, whatever types of key names you use, you have to be consistent. So if you use first name here with camel casing, where the second word has a capital, on the other side where you try and retrieve these values, you have to use exactly the same key, otherwise you won't retrieve the data. So you can bundle these extra pieces of data inside of your intent message, right? And then you can start your activity for a result and also request data. So what we're doing here is we're sending data, but we're also telling the the activity that we're sending the data to, that we also want to get a response as well. And the response information is defined by a constant over here, because you could imagine that there's multiple, there's possibly multiple secondary activities that might return information back. So we need some way of determining where the message is coming from. So I've just got a little constant that I have to find here. We'll just run the code and show you what happens. So if we send the message, we send this information over here, and then if we click on return data, right? So if we come over to the second activity, we can have a look at the onCreate method. You can see here that we're setting up the layout. We're setting up a toolbar as well. I'll talk more about toolbars next week. And then over here, we're using the intent objects get extras method to get this bundle of data. So the bundle of data is just a little, it's just a little hash map really of all of these keys that we put our data into the system before. So we can extract that out of our little map. We can output it to the Logcat console, and you can see over here it's getting dumped into the console. And it's also getting inserted into the user interface as well. So, you know, that gives you a couple of basic options of what you can do with that data that you've passed from one activity to another activity. From there, we've got this back button that we've defined with a on-click listener. So that is this button here, return data. So we also, if we want to model more complicated behavior, we might like to return some kind of information as well. And so if you want to do that, this is the way to do it. So you can return a message. That return message, it could be based on the data that you've assembled over here. That's actually what I'm doing. So you can put in a key. Again, these are just key value pairs. This is the key, this is the value, this is the key, this is the value. And the main thing that we are doing here is setting up this little map of keys and values, attaching that to our results over here using our set result method, and then calling the finish method. And so the finish method sends that particular intent message back to the previous activity that called this second activity. And the method that transitions us back to the previous activity is the finish method, just over here. And so if we click that, that is going to return us back to the previous screen over here. And I think it's, okay. And the data should come through, or it should come back to this. I'm not sure if it's showing up in the emulator. Oh, it is. It is. So you can see here, return value. It's prefixed what we sent to it before. And that information comes back to us through this little callback method called onActivityResult. So that that request code that we locked onto before and sent to the secondary activity, that has to match up, right? And if it matches up, and if the result code was result code okay, we can then get the little data bundle and get the data behind our result and also the data behind our payload. And my application here, it's not doing anything special. It's just putting the results back into our little widget, our little text result widget over here. And so that's the primary thing that I wanted to talk about this week. There is an example of with this little project that you've got, you already have this available on Moodle. There's also a little example of using the recycler view. That's a little bit too advanced right now. That's something that I think we'll cover off again in a few weeks' time. The recycler view is basically the built-in widget for, or it's the built-in list view widget in Android. So if you're feeling advanced, you can have a bit of a play around with that, but it's not, as I say, we won't look at that today because it's a bit more advanced. You have to have a good understanding of how fragments work, and they're a bit more of an advanced topic, and you don't need them for the first assignment. So I'll talk about that again in a couple of weeks' time, once we're a bit more comfortable with how everything works. But you're welcome, by all means, to have a look at that. And so that's pretty much everything that I wanted to talk about today. So we've looked at some of the things that you have to do for the assignment, the testing, the unit testing, some of the abstract data types that you might use for the first assignment, and also how you can tie those types of abstract data types, arrays, array lists, anything else you can think of, how you can tie that into a unit test, and how you can execute those unit tests in Android. Were there any questions, guys? Do the wireframes need to be interactive? And no, they don't. They definitely don't need to be interactive. And so we don't really have any activities as such for this week, but while we still have a little bit of class time, what I'd like you to do is to have a go at building the first assignment. And we've got a question from Robinson. So is it just the interface or the other pages? Could you be a bit more precise with your questions for the wireframe? Yeah, the wireframe, right? That will just be the wireframe for all of your activities in your application. So if you have one primary activity, you'll need a wireframe for that. But if there's any other activities, you'll also need wireframes for those as well. So anything that's visual, any kind of user interface in your application, there should be a wireframe. Okay, so I'm going to have a little break for about 5 minutes, and then I'll be back. Yeah, so please get started with the assignment. It looks like everybody is starting to work on the wireframes, so that's a reasonable place to get started. You might also like to get started on having a look at some of the core data structures and algorithms that you might like to use for your project as well. So I'll put all of this code up on Moodle. I've just talked about it. We've got a recording of it as well. This code, it still has its faults, as you can see with the failing unit tests over here. So if you choose to use this code to base your assignment on, that is a pretty big caveat. So you're going to have to fix that code up before you do anything else. Okay, so I'll be back in 5 minutes, guys, and then I'll put all of this code up and the other materials.